Hey everybody, this is Larry. This is me doing a bonus question that I haven't done before. I have to remember to set premium because for some reason it doesn't always do premium. Let's do a medium because I think I'm lacking a lot of mediums or something. And then, oh yeah, to do. And yeah, let's go. Go, and hopefully no SQL bomb. I really just need to do SQL bomb so that they don't come up. Alright, let's try again. I have to click on this again because that's, I don't know. Alright. Okay, that's good. Okay, today's extra Larry problem is 549, binary tree longest consecutive sequence 2. Alright, so given a root of a binary tree, return the length of the longest consecutive path in the tree. A consecutive path is a path where the rise of consecutive nodes in the path by 1, it could be increasing or decreasing. Okay. Does that have to be strictly? Okay, probably. The longest consecutive path is, does that have to be from root? Because I could, oh no, this is 2, 1, 3, okay. So what, this could be 1, 2, 3. I don't know why there's a thing over there. Okay, I mean, I think this is pretty straightforward, maybe. I mean, no, I wouldn't say straightforward, but I think the understanding is straightforward. I think it is just some sort of, you know, how do I phrase it? I mean, it's definitely just recursion, and you can do this in linear time. But I think it is just very, it is just very easy to make mistakes, is what I mean. So okay, but let's just get started then. Yeah. So, traverse, right? So then we have node and maybe the parent value, something like this. I'm not sure. I'm not sold on this, so don't hold me to it yet. But basically, and maybe a best variable that's outside. Maybe something like, yeah. I think one more thing that I wanted to do was something like delta or something, so that we could just be lazy about it. I mean, I think you can actually do the logic much more straightforward, but I am going to do the logic much dumber so I don't make silly mistakes, hopefully. So let's see, right? So basically now we want to see, so they're really, so basically there are really, there are a couple of scenarios, right? The scenario is that this current node is the root that it goes, basically it is the root of the subtree that contains the longest consecutive sequence, right? So that's one thing that we'll do. And it's basically either so basically it's either left, how do I phrase this? Let's say increasing, right? Left increasing is going to traverse node dot left, node is the parent, and delta in this case, let's just say increasing means that you're going up, so +1, right? Right decreasing in this case is go traverse node dot right, node -1, and basically your best is you go to, that's non-local at first, and then in this case best is equal to max of best left increasing plus right decreasing +1, right, for the current node. So that's basically just saying that left is going up, right is going down, and then you just kind of combine it that way. And then of course you have the other possibility of left decreasing, right increasing, and then this is just the same idea but symmetric, right? And then now, and this is actually ignoring delta because and the parent, because this is just assuming that this existing node is the node. So we don't have to care about the parent because this is the node that you turn your path or whatever, right? Otherwise, if node dot value minus parent dot value, let's just say if parent is not none, and if it is in, I just want to make sure my terms are right. If this is equal to plus delta, then okay, yeah. Basically, now this is saying that we are able to connect to the parent, then we return max of, oh wait, that's right. So if delta is equal to 1, that means that we're coming down an increasing path. So then we want to follow that in by left increasing, right increasing, plus 1, right? And then else we return max of left decreasing, right decreasing, plus 1. Otherwise we return 0, because that means that we do not match the parent, so we don't go up. We don't go up that way. None, and it just doesn't really matter. I think in this case I have to say delta is equal to -1 just to be precise. And then return best at the very end. Hopefully this is right. Oh, because we return none. Okay, fine. I mean, yeah, I mean, this is good. Or obviously, the test case is accepted as good, but I'm just trying to think whether that is... how much effort am I trying to do? All right, let's give it a submit. I'm not 100% sold on this. This is why I kind of hesitated. But yeah, shouldn't time out though. I'm gonna get time out and be sad. Huh? I'm actually surprised. I mean, I know that I do 2 of these, but one of these will always be wrong. Oh, I am dumb. Okay. Yeah, okay. I made a mistake. I assumed that one of these will always be wrong, so it'll be terminated early. But because we don't... I mean, yeah, I mean, it branches out because yeah, because each node is considered that by itself. I think I could just add a cache and be over with, to be honest. I am a little bit lazy today. But, I mean, so the right way to fix this, to be honest, is just by detangling the dependency that we have. Basically, right now, each one is calling the same path twice instead of a regular depth first search, and that's why this is causing an issue. I mean, you could definitely solve it with like just memorizing it, but there's actually probably a cleaner way to detangle them. But I mean, the right way is just to kind of separate them out and do it twice. But I think the caching is probably fine. I'm a little bit tired today. I don't know why. So I'm just gonna, yeah. Basically, the idea behind this memorization is that you can only call each node with 2 different input types. One is that the node, for every node, all the parent is always going to be the same, and delta can only be 1 and -1. So we only call... This is the equivalent of making it amortized depth first search twice, because you look at each node twice, and this is why this solves it. But honestly, I was being sloppy. I shouldn't have kind of resolved to this. There is definitely a cleaner way to kind of just there is definitely a cleaner way to do this, but I don't think I did it that way. Yeah, I don't know. Let me know what you think. Let me know if you have any questions. This is kind of an annoying one, actually, to be honest. But I mean, yeah, I guess I could have done it that way. I don't know. I'm just kind of the way that I did it. I think the way that I did it, I tried to do it, like I said, like very dumb. But maybe it was a little bit too dumb that I kind of messed myself up. Because I think you could just be really careful, right? You could separate out. You could separate out the two logic. One is processing each node as the root, and then the other logic is processing only the left or the right, depending on the delta, right? Like, and I think that would because these two things are more or less mutually exclusive. So I kind of try to do everything too much at the same time, but changing the case analysis, I don't know how I feel about it. I don't know. Let me know what you feel about this. Let me know if you have any questions. That's all I have for today, though. So let me know what you think. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.